Today, I'm speaking with Noam Gat, an algo developer here at AI21. We're going to talk about reward models, critique models, and judge language models, see what's the difference between them, and how you can use them for your benefits. Let's get started. Hi everybody, I'm here today with Noam. So, hi Noam.
Hi Yuval.
Tell me a bit about yourself. I know you for, I think, about a year now, right?
Mm-hmm. So I'm an algorithm developer here at AI21. I've been here for a year. And before that, I was working on AI for architecture and image generation. And way before that, I was the European champion for Tekken 4.
The European champion of Tekken 4.
Yeah, I'm trying to do something more meaningful with my life so I don't live in the shadow of my 16-year-old self.
So I do want to ask you, I'm asking that everybody, what is the first AI application you've ever built?
So the first one, I guess, would be almost 20 years ago. It wasn't like AI in the machine learning sense, but I built an AI for a computer game that you had to drive mice to holes and steal arrows from opponents. And I used the scoring-based mechanisms with some tweaks and data-driven learning for parameters and actually created something that I couldn't beat.
But someone else could? So you literally created something that you cannot, a rock that you cannot lift.
I created a rock that I cannot lift.
That's cool. That's interesting. I do want to ask you, what is a bad take on LLMs that really annoys you?
I don't like the LLMs are taking our jobs angle. I think there will always be humans in the loop and that people will find ways to be productive. So all this apocalyptic talk about we won't have jobs, only these people will get jobs, we need to find different careers, I don't think we're going there. But I might be proven wrong.
That was for LLMs. If I will say about AI agents, will you change your answer or?
No.
No? You do not believe that AI agents will take our jobs?
No. I think humans are essential.
By the way, I agree and fully on board with your approach. So that's a good point for you. A controversial opinion that you have about LLMs, generative AI.
So it was controversial until a month ago.
Okay.
I was always certain that real reinforcement learning is the key to the next step of what LLMs can do. And now with the DeepSeek R1, it seems like it's all the rage that everyone's talking about. But for me, it was finally, someone found the recipe to take us to the next step. And I do think that it's a beginning of the next chapter of how LLMs are trained.
So it may be a tangent, but I'm sorry, I'm really curious. So maybe we can still do a bit. When you mean that it was controversial, I'm not sure. I do know that there were papers that were claiming that RLHF is not really necessary. There was a lot of opinions that some side said, oh, it's just really hard, and some were no, you can really do it with SFT. You don't really have to go reinforcement learning. And unfortunately, I read a lot of the press of R1 press release, but not the actual paper. So I'm guessing that when you say that they made it uncontroversial, it means that they're using RL.
Yeah, they trained two models, and in one of the models, which was a key part of their process, they call it R10, if I remember correctly.
R10.
Yeah, they went straight from the pre-trained model to RL training, skipping the big SFT phase, which used to be considered the cornerstone of post-training, to actually turn the model into an assistant. And they were able to teach it very advanced forms of reasoning directly with verifiable reinforcement learning, which is different from RLHF, which you try to...
So it's even not the same as, it's a whole method of RL.
RLHF is actually closer to what we're going to be talking about today, reward modeling, but they used verifiable RL, where you have a task and you have a strict way to check whether the completion is good or not. So you can run reinforcement loops that are more similar to classic reinforcement learning rather than RLHF methods. And they show that if you correctly tune it, you can do a lot of what we try to do with SFT, but with RL. And so far, I mean, it's still early. We don't have many groups that reproduced their results yet. Maybe by the time this is aired, the answer to that will be different. But it does look like a very promising avenue of research. And I believe that like task-specific LLMs are going to be easier to train now that there's a recipe for using objective reinforcement learning.
Okay, so just like to maybe, for those of you who are not 100% remember the process, there's like the Andrew Karpathy, very, very famous lecture of how to build ChatGPT, where essentially the correct process is to do a pre-trained model, right, that really is really good in predicting the next word. This is something that takes hours, not hours, like it takes days, weeks, months, even.
Millions of dollars usually.
And lots and lots and lots and lots of money. Okay, this is what we call a base model or a pre-trained model. Then we're doing SFT, supervised fine-tuning, where there's a lot of high-quality examples, right? When you just show the model, this is what you need to do. And then like the next phase is to do RLHF, which apparently is different than what DeepSeek has done.
Yeah, the main difference is what gives the reward, what judges the response and says, this is a good response, this is a bad response. RLHF learns from human annotations and trains a model to give the score of this is a good response, this is a bad response. Whereas it's starting to be called verifiable RL nowadays. There's an actual code that looks at the response and say, oh, the answer should have been 9, but you said 12. That's a wrong answer. Or the answer is correct.
By a machine. So
like objectively verifiable goal. And that eliminates various problems of RLHF, which are categorized usually as reward hacking, where the model learns to optimize for the reward model, but that is not necessarily optimizing for being a good assistant.
So we may have been a bit on a tangent, but you did mention a lot about reward modeling. This episode is about judge language models. And I've also heard you say the word critic once and again in the office. Are they all the same?
Yeah, it's basically a category of problems, and because it's so new, then maybe different people use different terms for the same thing. So I'll try to be consistent with at least my language for this session.
I will adopt your language, so at least 2 people will say that.
Okay, so the term LLMs as judges is the category of language models that instead of generating helpful output, they give feedback about existing output. So they don't receive the user request, they actually receive the user request and the assistant response as input. And there are 2 kinds of models, basically. One is a reward model, which receives the conversation, including the assistant's response, and responds with a score, 4 out of 5. So that is a strictly numeric output. And a critic model is actually a normal LLM in the sense that it outputs text, but that text is going to be a critique of the assistant's performance in the conversation. So the critic generates critique. It might say, the assistant made a mathematical error, therefore the response is bad.
So the reward will say, I'm 3 out of 10, and the critic will say, you're ugly because, and these are the reasons.
Yeah, you can see this is a sort of schema that basically shows what types of problems we have with LLMs as judge and what type of models exist.
So just to make sure I understand, judge is like the umbrella name.
Yeah.
Critic gives you the actual feedback, and it's usually a language model prompted to do so. And reward is give you the number, and it's not a language model.
No, it outputs a single number. You don't have.
It cannot be a language model, like.
It is a language model in the insides, but it does not output language tokens like most models do. And you can solve different problems with it. You could say
the one that we're seeing in the slide.
Yeah.
Okay, so walk me through them.
So the classic one is sometimes called single rating or absolute judgment. I get a response and I say on a scale from 1 to 5, how good is this response? If you have two responses, then you might want to ask which response is better. Maybe they're both good and you want the really good one, or maybe they're both horrible and you want to discard both of them. And a third one is sometimes called a classification problem, where you can say, is this response a valid CSV table? Is this response in a lighthearted tone? These kinds of almost binary questions where you want to get a yes-no answer to them, but it's not the answer in general, it's a very specific criteria.
Got it. I think when you said the pairwise comparison, it really, clearly there is one thing that comes to mind, right?
So you might want to ask, okay, these models exist, but what business problem are they trying to achieve?
No, so actually I meant more I'm trying to understand the absolute is kind of clear, right? I have a completion, I have an answer. Is it good or is it not? We talk about pairwise, so clearly this is the first time that I'm talking about LLMs, I'm probably going to Google and I will find the chatbot, is it still called Chatbot Arena?
Yeah, Chatbot Arena.
Okay, so this is a good example for that, right?
Yeah.
This is okay, so for those of you who, I'm guessing almost everybody knows that, but for those of you who are not, I do recommend to go there. It's really nice to play with that. You just write yourself some sort of a prompt and then you're getting several answers and you have to rate them. Right, so this is a pairwise...
Yeah, in LMArena you get two responses from two different models and you pick your favorite. So training a pairwise reward model is almost like predicting what the person will choose when they go to LMArena.
But not necessarily.
But not necessarily.
Okay, and you can use both of them, like the models that are trained for pairwise or models that are trained for absolute. Are there different models?
So there are various technical properties that I think we're going to dive into them in a few minutes.
I'm getting ahead of myself, you're saying.
Yeah, but yes, there are differences. Some methods give you a model that can be used for all cases, and some are for specific cases. The details start to really matter when you go into that categorization.
Okay, so from what I understand right now, essentially I can either give it a few prompts, so I can do a arena of LLMs, which is nice. I can generate some answers, right, from my things that I'm writing in ChatGPT or something and see if it's good, automatic way. But where do we actually use them? Is it...
So I'll separate the use cases into two types of use cases. One is if your goal is to create a good language model, and two is if you want to use the existing model in a business use case. So we'll start with one, and that is how can you use reward models to train better models, and that is RLHF. For example, you can take your model, you can sample it 8 times, you can use the reward model
just to clarify, when you say when you sample it,
you ask your model to generate 8 responses. You use temperatures to create variety in those responses.
Okay, so sample is getting 8 different responses, essentially. Yeah. Okay, cool.
And then you can use the reward model to grade the responses. And basically, the learning step is telling the model that you're training, this is good, this is not as good. Be more like this. And when you iterate this over and over again, you will get a model that consistently outputs the result that get high scores in your reward model. So you are making it consistently be its best version. When you train it, that's generally, I'm not going into too many details, that is RLHF in a nutshell.
This is something I can do, I don't have to do it in the pre-training process, right? I can take a small model from Hugging Face and use a reward model and then just train according to my data.
Yeah,
right?
That is often not necessarily according to your data, though you can use your prompts as like the data source, but that is often the last step of training a model. If you go to the technical papers of, let's say, the past year, but not the past month, it's usually pre-training, then SFT, then preference training, which is pairs of good and bad, and then most common is PPO, which is one of the algorithms that uses a reward model to improve the model as a final last nudge to the right direction.
That was introduced by OpenAI, right? If I remember correctly.
I don't remember who originated it, but almost all of the models that came out in 2024 used some variation of this recipe.
Okay, cool.
So that is if you are training a language model.
And this is strictly using reward model, right? The numeric one.
Yeah. However, if you are a user of language models, then you might do the same things in inference time. We are seeing this be more and more common as the industry moves from language models to systems or agentic workflows, where actually during inference, you can use the reward model. If you know that it's very important to get this specific thing right, then you can call the LLM several times, give the reward model the task of giving a score to each of the responses, and pick the best one, giving your business users a better response. So many things, if you want to give your users a good response, most of today's agentic frameworks, like what we're doing here at AI21, or things like LangChain, they have the best of n concept, where you call the language model several times, use a reward model to grade the responses, and proceed with the best one. If you have a critic model, then you can also verify that the output is correct. For example, if you're looking to create a table because your user wants some kind of information that requires structured output, then you can critique the output and ask, is this a CSV table that explains A, B, C? And the critic can give you verbal response of, this column is missing, or the CSV is not properly formed. And you can actually give the critic's feedback as the next step for the language model to revise and fix the issues. So these are called revision loops. And this basically slide here shows the best or the most common use cases of reward models and critic models in agentic workflows. But generally, any business flow that wants to put in more inference, meaning spend more dollars per response in order to raise the quality, then it can use this method, given that they have a reward model or a critic model that they trust.
Yeah, so we know that there's a trade-off, right, between quality and cost a lot of the times. Like if you're willing to spend more money, you can maybe verify, or like these are essentially statistic models. Just like to make sure that I completely understand, when we're talking about the best of n, it's just like these are the conclusions that we have, just take the best one and continue. Whereas when we talk about a critic model, to incorporate, so there is always a loop, right? You always have to like get the okay from that, or you have to loop it with the feedback to no, generate again. So this was bad.
That's the difference between the best of n, which is a parallel approach, and the revision loops, which are a serial approach that is iterative, but on the same chain of responses.
You've mentioned several things you can do with reward models. Any examples for more things that people can actually take?
So something that we did internally that helped us quite a bit is to use it for filtering. So if we get some data source that we want to use for training, but we're afraid that there might be bad examples there, then we can just filter it by passing all of it through the reward model and keeping only the top 70%. And if the reward models can filter out the garbage, then even if some legitimate answers are thrown out, we still have a much cleaner data set that we can use without fear of contamination of what we've built.
So that's great. And by the way, this is something that a lot of people fall for. The garbage in, garbage out thing that's like a real problem. Okay, and even if you have a lot of data, it's more important that the data that you have will be cleaner and in higher quality than that you will just have a large amount of data. So what Noam said, you can just use a reward model to filter out a lot of the garbage, even if something good falls out, it's still better. And you said that it works, right?
Yeah, we have great results.
So it significantly, you would say it significantly improved the results? So that's great. So just another example of something you can do without actually really knowing what a reward model is.
Right.
You mentioned before a language model or a judge you can trust. How can you trust?
So it's a good question. If you want to pick up a reward model or a critic model and use it to filter your responses or to grade them, you need to trust your responses. And the way we work in the industry is via benchmarks. So today, I would say there is one leading benchmark, which is called RewardBench.
RewardBench.
And a few other benchmarks that we might get to in a few
How many
minutes.
benchmark would you, in total, what would you estimate there will be?
So there's no end to benchmarks. If you look at standard language models, there's dozens of them, popular ones. For reward modeling, I think there's one clear-cut leader right now in terms of popularity, which is RewardBench, which actually, if we talked about LMArena or Chatbot Arena a few minutes ago, then it's the same setting. They take the same prompt, 2 different answers, give human annotators to judge which one is better, and that's the data set that you have to evaluate. So the reward model is tested on its ability to mimic the gradings of the human annotators that evaluated the data. There are a few sub-data sets there depending on sources of data and the sources of the completions, but that's considered the #1 thing to look at. And there's even a leaderboard for RewardBench. So you can go online, Google RewardBench leaderboard, and you'll get the top 10 reward models today. Not all of them are available for download. Not all of them are available for commercial use, but you will be able to find out what you can use for your use case.
Any names that will be familiar for me or from the crowd?
I think the most popular one from the past year is NVIDIA's Nemotron. They have 2 flavors, one on their model from August, which is commercially usable, and another one that is based on Llama 3.1, which is usable under the Llama license, which may work for you, may not work for you. As a general principle, don't use a reward model or any model before checking its license. It's very important. Don't cut that corner.
These words were written by...
I've fortunately never made the mistake because I read licenses before I do things.
I don't. So
Start.
Well, whatever Noam said right now, listen to him.
So anyway, I think Nemotron by NVIDIA, either one of the flavors is a great starting point. It gets very high scores on RewardBench. But when we evaluated it internally for our uses, we saw that there are various problems with it. And I'm not trying to say it's a bad model, but you do have to take into account the kind of data that it was trained on. And that lends to the kind of tasks that it's good on and the kind of tasks that it may have not seen in the training, and therefore it's less accurate on. That's why we have benchmarks.
Yeah, I think it's also a good point that, right, there's state of the art, but nothing can really be good at everything, right? It's kind of state of the art because it's good in the majority, I guess, or
at least not as of today.
Not as of today.
So another good benchmark, it's actually a benchmark suite by LMArena, the same company that made Chatbot Arena.
The LMSys. Okay.
It's called the PPE, Proximal Policy Estimation, maybe. And it's a set of benchmarks. Some of them is similar to RewardBench, that you have human gradings and the model has to guess which response the human preferred. And some of them are objective benchmarks. For example, they take a prompt, they add an instruction such as make the response entirely lowercase, and then they generate responses. Some of them are completely lowercase, some of them are not, and they check, the benchmark checks whether the reward model finds the problem. So if the prompt requested lowercase, for example, and the response is not lowercase, the reward model should give a low score because there is a violation of the request. So this is what we often call an objective judgment request, where there is a ground truth.
I've heard you say objective in this podcast already, right?
The question of objective versus preference or subjective judgment is an ongoing thing because it's different type of tasks. Yeah. So RewardBench, in a sense, is completely preference-oriented, while the LMArena benchmark suite also contains things that the reward model should find mistakes in. And you can see that Nemotron is not, if in RewardBench, for example, we're talking about above 90% success. That's a very high success rate of accuracy. Nemotron was the first one to pass the 90% bar. That's why it holds a special point. But by now, everyone passed it, because once the secret is out, then everyone can reproduce it.
Everyone knows.
But in the LMArena, you can see they also have leaderboards for their new suites. Some of their sub-benchmarks are below 70. So there's still a lot of progress to be made in this field of reward modeling.
A low grade for state-of-the-art in a benchmark is like right? It's a challenge accepted kind of
basically
kind of thing.
So I do think there are still strides to be made in this domain.
Just like to make sure I understand, so because the example you gave was lowercase. So essentially, these are all tasks that I can verify with like a simple Python script or something. That's how we get the objective part?
That's how the data is created for the benchmark. It's supposed to simulate a real-world scenario in which the user just types in free text what they want the response to look at. And we hope, as benchmark builders, that if a model is good in this case, then it will also be good in the more natural, real-world scenarios, where you don't necessarily have a Python script to check whether the response upholds a certain quality.
Did you see some sort of correlation?
So if you can see in this graph, then in our benchmarks, we both used the LMArena objective set and also created some internal benchmarks for ourselves that are closer to what our users, what our enterprise customers want in their usage of LLMs. And we see that we can get much higher scores if we know what we are optimizing for. So this clearly demonstrates, again, Nemotron is a great model. They made, I think, substantial research advancements in the data that they released. But you still have to take care of the use cases that matter for you.
Yeah, so we definitely love Nemotron, by the way. Shout out for NVIDIA for releasing that reward. Can you explain what we're seeing here? What are the tasks?
So what we see here are some tasks that our customers face a lot of. And we talked about custom constraints in natural language. So we created a data set for that, not just structured.
Give me an example for a custom constraint in natural language.
So for example, if you want the AI to write a blog post, and you want to say every mention of my product should be in a positive light and every mention of a customer's product needs to be in a negative light.
That's a very hard constraint.
It's a constraint, but that is something that, for example, Nemotron has not very high accuracy in, because the response, the complete response, might still be a very good blog post with very good information, but it doesn't necessarily capture the specific request that you had. And this is the difference between global ranking, which Nemotron is great at, and fine-grained requests and judgment requests, which is not what it was trained for. So we have some internal benchmarks that we did, and they also constitute of the custom training data that we created in order to succeed in these benchmarks.
So Noam, this is a very nice graph. How did we get there?
So we trained our own reward model, not a critic. A reward model, a critic gives text, the reward model gives a point. And there's several flavors of how you can train these models. One is called the regression-based method, which basically you give training data of this response should be a 5 out of 10, this response should be a 7 out of 10.
So you have to like annotate yourself the grade.
Yeah,
for
and
something.
actually if we talk about Nemotron, one of the things NVIDIA did was release a regression data set that you can trade your reward model with.
That's how everybody else got to 90 on the RewardBench?
That's one of the reasons why everyone has 90 now. And the other method is called the Bradley-Terry method, where you give the model pairs and you say, I don't care what the score is, but this response needs to score higher than this response. And then that contrast trains a reward model.
This is like a relative.
Yeah, that's a relative. And actually the second evolution of Nemotron adds Bradley-Terry training on top of the regression training. So the two methods can interact. But these are the classic methods for training a reward model.
When you say that they're both interact, it means that the output is both a score and a relative, or? No,
the relative, the Bradley-Terry method still trains the model to output one score. The model doesn't receive both responses. It receives one of them at a time and gives it the score. And then the difference between them is what translates into the loss that the language model learns. So the task, if I try to translate the math into words, is give this a score, give this a score, make sure that this one is higher than this one. That's Bradley-Terry in very inaccurate math speak.
What we like to say, waving hands?
Yeah, the short version.
The short version, okay.
And we use the Bradley-Terry method with our own custom data that we create for it, which also can be used if I go to how to train a critic model. Then the popular method today is one that a few companies and a few research papers showed. Salesforce released a paper called Direct Judgment Preference Optimization, DJPO.
Very catchy.
Very catchy, which is basically like DPO, but for judgment tasks. So these results, these methods, while similar, do have their nuances. And these are the architectures that are used for today's reward and critic models.
I kind of thought that like the mainstream critic model is essentially just call like an LLM with a long prompt of do this with those guidelines. So like, a lot of people actually train their own critic models. So you mentioned Bradley-Terry, which I'm referring, this is the method that we actually use here.
Yeah, it's the one that most of the leading reward models use. And it's a contrastive based learning method. You say, this should get a higher score than this. The upside of that method is that it gets good results on RewardBench. The downside is that sometimes the scores themselves kind of spiral out of control. So I don't tell the model, this should be a 10, this should be a 5. I say, this should be higher than this. So the question is, what score is it supposed to give? It doesn't have to give a specific score. And we actually see that some models give a score between 3 to -80. And
why not?
Why?
10?
Because
like 0 to 10?
Because they weren't trained to do so. And there's a problem with that because you aren't able to use that model as a single absolute ranking. Because if you get a prompt and a completion and you get a -10, is that a good thing? Is that a bad thing? They even, in their usage guides, they say, don't use this to give a score, only use it to compare different responses for the same prompt. So they say they're only good for the best of n use case, but not for the single completion or fine-grained use cases. What we did in AI21 is we actually added a range regularization term to the Bradley-Terry loss to create a score that is singular and usable in that sense. So not
-80 to 3. I'm guessing. Yeah. I'm hoping.
I hope. And actually, the regularization term is part of why we improved the benchmarks. When we compare to Nemotron, Nemotron reward has a very big, it's called uncalibrated, where you can trust the score only when you compare it to a different score for the same prompt.
So now it's not enough that I have to read the license, I also have to read the guidance.
Yeah.
Right? So a lot of the things I have to read after your conversation with you.
Don't skip the read me either.
Read the friendly manual, like they say. Okay, so we talked about how we train the model, but I think there is a point missing, right? Like the main thing every time you train a model,
the data. Right. So we created additional to the open data sets. We created some proprietary data sets with things that we have, and we use contrastive pairs to create judgment tasks from the data. And I'll give an example of what you can do in a research environment.
Okay.
So you can take a prompt database that mimics normal use cases like Shared GPT, which is a collection that is usable for research purposes. And it contains general prompts like, tell me what I can do in France for a week, or those kind of general purpose prompts.
What can you do in France for a week?
I don't know, ask a model.
Ask a model, okay.
And we take an instruction following data set from Google. It's called Yuval. It contains a set of instructions and Python code to verify. And we can take the prompts from Shared GPT, add instructions to them, check with the Python code if the completions are right or wrong, so we know if they should be a good score or a bad score. And we can use this concept to train both a reward model and a critic model by using good and bad judgments. So if you can see here.
Yeah, another graph.
Yeah, this it's not a graph, it's a scheme. It shows the basic concept of how we train the reward model and the critic model. We collect good and bad assistant operations, good and bad critiques or judgments of those assistant operations, and this gives us a balanced preference data set that we can use techniques such as DPO or SFT, or in the reward model case, Bradley-Terry loss, to create the contrast between the good responses and the bad responses to make sure that we correctly judge them. So these 2x2 contrastive pairs are the main way we train reward models in a calibrated way to be able to assess the needs of our clients.
Just to make sure, when you say calibrated way, you mean?
That we are also able to use that model to judge a single response.
The thing that you said about making the number to be not between minus 80.
Like that I know that if I get a 7 out of 10, it's good. And if I get a 3 out of 10, it's bad. Something I can trust.
Put that in our manual then, I guess. Cool, so we see here like a nice balance between good and bad completions, right? This is kind of, right, it's a way of reinforcement learning to train this.
Yeah, this can be seen as a preference data set, which is like offline RL.
Okay, that's cool.
And again, this model, I'm not saying that we built the best model in the world for any use case. Maybe that's next week. But we were able to understand what our clients need, created the data sets both for evaluation and training that respond to those needs and those use cases. And that's how we know that we cover our bases.
So you mentioned offline reinforcement learning, objective, which kind of reminds me we talked about DeepSeek in the beginning. So how does it affect about this?
So it's a good question. First of all, you can ask, do we even need reward models and critic models if DeepSeek R1 is such a good reasoning engine?
And do we?
And so it's not bad as a language model, as a critic model. We benchmarked it. It's not top 5 or top 10, but it does very good for a model that wasn't specifically trained to be a judge model. So you can use DeepSeek R1 as the critic and get pretty good results. You can get better results, but pretty good. But the training methods behind it, I think, are going to affect how judge language models are trained. And one of the things that I'm looking into right now is taking the judgment task from the previous section that we discussed and turning it into an online RL method where the model can continuously improve its ability to critique responses with an objective signal on whether the response should be graded good or bad. And I do think that we're going to see another jump in critique models using these methods in the coming months.
The model will essentially be improved in each iteration, and each time it will learn something?
Yeah. So I think DeepSeek's R1 RL method can be applied to critique model training, that you basically give the task of critiquing a response with the ground truth of good or bad, and that will change how critique models are trained in the coming months.
Will it change like significantly quality, or just much faster, much easier?
I think both. I think it will be easier to create data for training a critic model, and we will see higher scores in the LMArena benchmarks.
That's cool. Okay, Noam, so let's wrap it up. Let's just make sure that we understand everything we talked about. So can you just remind me, summarize, what is the difference between a judge, a critic, and a reward model?
A critic gives verbal feedback about the responses. A reward model gives a score, a number, and the judge is just the categorization of everything into one family of models.
Okay, and let's say I want to choose a reward model. How to do it the best way?
You have to look at the benchmarks, and even better, create your own benchmarks so you can really see how it performs for your use case.
Name the top 2 benchmarks in reward models.
RewardBench and LMArena PPE.
Okay. And how can I get a sense to, let's say I found the top 3 models. How can I understand which one is the best for me?
Test on your data.
What's the biggest myth about reward language models?
That RewardBench is everything that counts.
And it's not?
It's not.
Okay. One last thing. What is a tip you can say for anybody who uses reward models or want to build one of their own?
Understand what you're trying to achieve with your model and optimize your data, your architecture, and your benchmarks for that.
Right. Well, thanks, Noam. I had a great time with you. Everything we mentioned here, all the smart references Noam made will be in the description, so make sure to check them out. And see you next time.